All right, so we're going to approximate this definite integral with three different methods. We got the trapezoidal rule, the midpoint rule, and Simpson's rule. And we're going to do all of them with 8 subintervals. So we'll start with the trapezoidal rule. We can write that as t sub 8. Excuse me, t for the trapezoidal, and then the sub 8 for the number of subintervals. So if you remember the form, well, I guess we're going to need delta x for everything. So let's get delta x real quick. Delta x is the difference in the limits over the number of subintervals. So delta x is a half. And we'll start with the trapezoidal rule. So remember, for the trapezoidal rule, it's actually an average of 2 other approximation methods. So we've got delta x, which I'm just going to fill this in, is a half. But then we got to divide it by 2. And then for the trapezoidal rule, every term save for the first term and the last term gets used up twice. And remember, that was because this actually is an average. If I can group this a little bit. There we go. So we've got f of our a, which is 0. It starts at a. The trapezoidal rule starts at whatever your a is. And then we're going to go in delta x multiples all the way to 4. But from here on out, we've got to double every y value. So we're going to have 2 f of our next x is a half, plus 2 times our next f is going to be 1, plus 2 times our next f, which is 1/2, or 1.5, or 3/2. And then we got to keep going until our last term, which again is back to a single y, and this one stops at the b itself, the endpoint. So every other y value gets counted twice, save for the first term and the last term, and then we have to divide it by 2. Okay, so the hard part, I guess, is calculating this. I think is just the tediousness of calculating this. One thing you do is what I was doing. I was trying a few things, but the only method I really got to work was just loading this into y1, right, x cubed sine x, and then making sure that when you hit the second window where it says table set on your calculator, make sure your independent variable is set to ask. That way you can go to the table, the second graph on the calculator, and then you start plugging in 0, half, 1, 3/2, excuse me, to get those numbers. And then again, the hardest part is you got to remember to double all of the y values, save for the first and the last. And then you also can't forget to multiply the whole thing by a fourth, right? Because this is really a fourth. So a lot of calculation there. But again, we're just getting all of the y values, adding them all up. You're going to add up the middle ones twice, and then multiply by the fourth. So if you do all that, let's see, the answer, I took that time to do that already. So the answer is this negative 7.276910. The 0 is necessary to say it was rounded, because it was rounded and we went to 6 decimal places. So that is the trapezoidal rule. Now the midpoint rule is, we can write that as m sub 8. Now the midpoint rule is not an average of 2 other methods. It's just, we just have a delta x out front. So we've got 1/2 as our delta x. And we're just going to take the midpoint of all of these multiples of delta x, right? So we actually have a nice list up top. So if you were to start at 0, our next delta x would take us to a half. Well, the midpoint of that is a fourth. So we've got f of a fourth. And then you could say, hey, well, the next set of pairs here is a half and 1 in terms of x. So the midpoint is 3/4. Or you can just notice that, again, delta x is still a half. So we can just add a half, or delta x, to each of these x's as we move left to right. And we're not using any of the y values here. So we're not double using any y values. It's just the coefficients are 1 the whole way across. So a little bit easier to calculate. So this would be 3/4. 3/4. So we're adding 2/4 at a time. So it'll be 5/4 plus 7/4. And we got to go, I'm going to do another dot, dot, dot here. So we're going to be adding a half at a time, right? 5/4, 7/4. If we add another half, that's 9/4, and so on. We got to go all the way to 4. So 4 is 16/4. Remember, that's the last point, 16/4, and we got to take the midpoint. So we actually got to take 1/4 left because we're looking at the midpoint between 16/4 and the preceding delta x was what's that? 14/4, right? So we're actually interested in the midpoint, which is the 15/4. So you're going to go all the way to 15/4 here. And again, you're just adding a half at a time, starting at the 1/4. So we'll close parentheses, so you got to do all that. Luckily, we don't have to worry about doubling any of the y's now. But add all those values up, and if you do that, you should get, just going to make some room here. So if you multiply, or if you work this out, don't forget to multiply by half, we get this number here. And if you remember, this is always, the trapezoidal rule was always an under approximation. So it's certainly larger than this negative 7.27. The midpoint rule is generally one of the stronger ones, so it's probably closer to this negative 4.81. We can get an even better approximation than with the Simpsons rule. So we'll do a Simpsons S sub 8, and then we'll consider Simpsons rule. Remember, Simpsons rule actually has a delta x over 3. Delta x over 3. And Simpsons rule starts at A and ends at B. Moving at delta x multiples, so it's going to start at the 0, right? So we get f of 0. And with the Simpsons rule, our coefficients are a little bit different though. Same exact terms. We're going to start at a single 1, but then we go to 4. So we've got 4 f of a half, and then we use 2 f of 1. Then we go back to a 4 f of our 3/2. And maybe I'll extend this one out a little further rather than just going right to a dot, dot, dot. This pattern will continue until the end, the last term having a coefficient of 1. So it would be 2, 4, then we got another 2. So this would be 2 times f of, what are we at? 4/2, so it'll be 2. Plus 4 times f of 5/2. Well, let's just finish this one. Let me get an arrow. Not many more terms left. Okay, so red pen. All right, so we got 2 times f of, no, we were at 5/2, so we're at 6/2 now. 6/2 is 3. Plus 4 times, now we're at 7/2. And then since we had to go to 4, which is 8/2, our last term is just going to be f of 8/2. Remember, the last term does not have, well, has a coefficient of 1. So we need one more f of 4 itself. All right, so if you do all that, this comes out to be, that's bugging me, let me fix that. F of, we're talking f of 8/2, which is 4. All right, so calculate all those terms, add them up, multiply the result by a 1/6, and that was the coefficient up front here. So if you do all that, you should get this as an answer, which we know to be, amongst these 3 methods, the most accurate. And now there's, remember, now it's not going to be on the test, but within chapter 7.7, right, there was other problems where you could not only use, we're not only using Simpson's rule to calculate within a certain amount of accuracy the definite integral, but we can actually know specifically what that level of accuracy is. But anyways, we've answered the question. So amongst these 3, the most accurate would be the Simpson's rule. And yep, that's it. Okay, take care. Thank you. Bye.